I'm very excited about this. It was so weird that I don't know, like you lady was falling on you walk. Like you saw that? Yeah. I was like, did you see that? I'm like, oh, yeah. Yes, I did. She's watching it. Okay.
Hi, I'm Anna. And we're doing ionic radius. So I know what you guys are thinking, how is an ion affected? I'm glad you asked. If it loses an electron, it gets smaller. And that's because when you lose electrons, you sometimes get an empty outer orbital, which makes it smaller, as well as that the electrical repulsion is now has fewer number of remaining electrons. This is one position.
You can put it all the way in the corner, that's
Hit it, Jen.
Fewer number of remaining electrons decreases, allowing it to move closer to the nucleus. It gains electrons.
So when it gains electrons, it gets larger, and there's an increase in the electrostatic repulsion, causing the electrons to move farther apart.
Because electrons have similar spins or has similar charge, and so when things have similar charge, they repulse. And so let's make a little mind move here. Let's pretend these fabulous people were electrons. We're kind of in our own space. Let's get away from me, kind of thing, right? Right? But let's say, hey, I'm going to go and visit some other high reactive halogen. We'll see what happens. They get closer. So when it loses an electron, it gets smaller. You see what's going on here? You see what's going on here?
Yeah.
Yes.
I like the visual.
It's gonna get, yeah. So, see, look, yeah, and I'm come back, then I trip on the way here.
And Cheyenne, you can enter the circle, so
Yeah.
you can show what happens. when
Yeah,
you-
let's say Cheyenne, come walk with us. And it's like, whoa, we don't like you. You need your own space. Okay, now you can go around. So, and that's, and so that's how that shindig goes down. So, we'll ask those questions later after we continue with our presentation. Lauren, you want to hit this up?
Shows what the period decreases, left to right across the period, the size of positive ions decrease. Beginning of group 5A or 6A, size of much larger negative ions decreases.
So what this is saying is that left, which is on this side, or
You can use periodic table.
left. So this side,
Use the.
Oh,
you have
I'm
it
just
wrong
looking
on
at
here.
this, I promise. I'll pull it back.
so here, increase, I can show this up.
Oh,
It increases in size because what we learned was there a couple of days ago that, let's say, would we say boron, we treated boron as a metal?
I think you did, yes.
So boron lost electrons.
Good.
Right, yes. And so it got smaller, but why did you say increase? Yeah, they lost electrons, whether they get bigger, they get smaller.
Yeah, so that's what's weird about the ionic radius. As it goes up and then it goes back down and then it goes up again. So, in general, this is gaining 3, 2, 1. So,
They're big.
so they get more and more bigger. Let's say if we included this as a gaining, then this would be 4. So this gains 1, 2, 3, 4. So if you look at the size, it gets bigger on the non-metal side. And then, just like you said, if you start here, if you assume that this is a metal and it's losing, this is losing 3, that's losing two, and that's losing one.
And so it gets, yeah.
This loses the most, so it's as if you get all four of you in the circle, or actually three of you in the circle and all of you are gone. And all you're left with is those two inner circles. So you've lost the shell, and now that those two that are in the shell are really sucked in.
Yeah, okay.
And then that loses two and that loses one. So it's just like you say, you're losing this here and losing here.
So that's how that all happens.
Yeah. It is a weird trend. That's why I said that is the most difficult. I love the way you explained it with your
Acting?
Yeah.
Plan going back way.
Smiley face.
Yes, that's how trends within groups. Nicholas, do you wanna dazzle them?
So, within the groups, the outer electrons are in higher quantum energy levels, resulting in a gradual increase in the ionic size. So both positive and negative increases as you move down the group.
Yes. You keep adding shells of electrons. Keep adding.
And so it would obviously just get bigger. Keep on putting those sweaters on, you're just gonna get round up. So, you guys ready to be tested?
Yes.
Wow, there's a lot more excitement there than I really expected, that's awesome. All right, so question number 1. If you add an electron, what happens to the ionic radius? It gets bigger. And why is that, Jen? Because of the electrostatic repulsion, which says, hey, we have the same spins, or we have the same charge, I don't like you, go away. That's basically what it's saying. Yeah, Mean Girl, it's like Lindsay Lohan, like off of Mean Girls, not that I have anything against Lindsay Lohan. Question number 2, if you lose an electron, what happens to the ionic radius? Because
They come together.
These electrons, so
it's nothing else, as long as you know the word electrostatic repulsion, I'll be happy. It gets smaller because they have more room, they don't need more space. There's less of them, and they say, oh, okay, we can get closer now. So, that's about our spiel.
Good. Give her a round of applause. All right, so now Mrs. Harkin's gonna quiz you. I love how you ask a question and then you ask a deeper question. So that way you didn't let anybody off the hook. Good job, group. All right, so I'm still gonna put on the hook. Okay, atomic radius. Without looking at your charts, your cheat sheet, which has the larger, ionic radius, which has the higher ionic radius, a magnesium ion or a radium ion? Radium. A zinc ion or a mercury ion? Mercury. Which has the greater radius, a fluorine ion or a nitrogen ion?
Nitrogen.
Nitrogen. It's going this way. Okay, which has a higher ionic radius, magnesium or sodium ion? Sodium. Which has a higher ionic radius, lead or mercury? Mercury. So as you go across, it gets bigger. As you go down, it gets bigger. And it kind of does one of these a little bit. It's got like a mountain. But in general, that's the trend. Okay, I'll never give you right where the mountain drops off. I'll always give you part of the mountain slope. Okay, good job. Okay, we are